Okay, so we have this system of equations and we want to use echelon method to solve. So I have row 1 and a row 2 here. The first goal is to get a 1 for the coefficient of the x in the first equation. So I want a 1 there. Now the two ways to get a 1 are either to switch two rows, if there's another 1 conveniently already there, or I can multiply by the reciprocal. In this case, because there's not a 1 conveniently when the other x coefficient, I'm going to need to multiply by the reciprocal. The reciprocal of 2 is 1 over 2. I'm going to multiply that by row 1 and put it back into row 1. So if you want to think about it as multiply by a half, or you can think about it as divide by 2 if that makes you feel better. We don't actually write divide by 2 because that's not an operation, a row that we're allowed to use. We are allowed to multiply by a number, we can't divide by a number. So you have to write it as multiply by 1/2, but in your head you can probably think about it as divide by 2. So 2 divided by 2 is x, 1x. 3 divided by 2, well that doesn't reduce, so that's 3/2 y, equals 12 divided by 2, that's 6. What happens to row 2? Well, nothing, it just stays the same. So for the next step, I want to get a 0 for the 3x term. I want a 0 for the coefficient. Now, to get a 0, the steps for getting a 0 is you take the opposite of 3, which is -3, times it by the row with a 1 in it, which is row 1, and add it back to the row that you're manipulating. This is going to replace row 2. So row 1 is going to stay the same. So I'm going to do my work off to the side here. Remember, I've decided to multiply everything by -3, so I'm going to multiply this by -3 to every single term in row 1. So over on the side here, I have -3 times x, which is -3x. -3 times 3/2. Remember, just multiply the tops. That's -9 over 2, and that doesn't reduce. Y equals 6 times -3 is -18. I'm going to add row 2 to that, so I'm just going to put row 2 right up underneath it. The x's add to 0, and I get the 0x that I want. Yay. But now I have to add these fractions. So -9/2 minus 4 over 1. I want an LCD of 2. So for the first equation, I don't have to do anything, or if you want to think about it as a multiply by 1, you can. For the second equation, I have a 1 and I need a 2. So if I'm going to multiply the denominator by 2, I also then have to multiply the numerator by 2. So now the denominators are the same too, and I can add or subtract the numerators, which is -17 over 2y. -18 plus 1, that's just -17. So that replaces the second equation. Excellent. So let's go back to our checklist here. I've got a 1 where I want it, yay, check. I've got a 0 below it, yay, check. So the next thing that I'm trying to do is I would like a 1 in front of the y. So that's what I'm going to work on next, getting a 1 in front of the y. So to get a 1, I need to multiply by the reciprocal. The reciprocal of -17 over 2 is 2 over -17. If the number is negative, then the reciprocal is also negative. A lot of students have a hard time with that one. So I'm going to take the reciprocal, which is 2 over -17, times row 2, put it back into row 2. What happens to row 1? Nothing. Row 1 stays the same. So if I'm multiplying by 2 over -17 on both sides, notice the 17s, -17s divide out, the 2's divide out, and even on the right side, the -17s divide out, and you're just left with 2. I have this now in echelon form, so the next thing I need to do is back substitute. So I already know that y is equal to 2. All I need to do is find x. So I'm going to put x plus 3/2 times y equals 6, but I know y is 2. The 2's divide out nicely, and I get x plus 3 equals 6. And then a simple solve to get x equals 3. And that is my solution. I could check my solution if I really wanted to by plugging in my solution into both equations. It should work. 2 times x, which is 3, plus 3 times y, which is 2, should equal 12. And it does. 6 plus 6 equals 12. It does check out for the first equation. For the second equation, I have 3 times 3 minus 4 times y, which is 2, and that's supposedly equal to 1. And yep, 9 minus 8 sure does equal 1. So I did do this one correctly. The check is optional. For our next example, for step 1, I want to get a 1 in the first equation for the x coefficient. I don't have another 1 in another equation, so switching 2 rows isn't actually going to help me. So I have to use multiply by the reciprocal. The reciprocal of 2 is 1/2. So I have 1/2 times row 1 back into row 1. So if I'm taking this and multiplying it by 1/2 to every single term in the first row equation, that gives me 1x minus 3 over 2y equals 3. Row 2 isn't changed because I didn't mention row 2 at all up here in my replace statement. Alright, so step 1 is done. I have the 1 where I want it. My next goal is to get a 0 below it. The way I get a 0 below it is I take the opposite of -4. The -4 is negative, so the opposite would be +4, times the row with the 1 in it that I just got, that would be row 1. Add it back to row 2 and put it in row 2. So row 1 is actually going to stay the same. So I can go ahead and move that in. And I'm going to do my work off to the side here. Getting zeros takes a little bit of work. So I'm going to multiply by 4 to every single term in the first row. So that's 4x minus, again, fractions and whole numbers are not that bad. You just multiply the two tops. 3 times 4 is 12. And then take that product and divide by the denominator. 12 divided by 2 is 6. 3 times 4 is 12. Then put the row 2 right below it. And then I add. So 4x minus 4x is 0. That's what I wanted. Hooray! I'm not surprised because that's what I was forcing to have happen. But what accidentally also happened is my y's added is 0. So I have 0 equals 24. At this point, I can't go any further. I can't make this a 1 because it's a 0 and there's no y there at all. So at this point, I can look at 0 equals 24 and realize that this is a not true number statement. Because it's not true, I can stop the whole problem, and this is just going to be a no solution problem.